Well, queuing theory, we may have the formula to have for the M1, but let us have some fundamental idea to have the calculation of queuing theory, queuing delay. So right now, I try to have some extra example. So let me have the empty page first. Well, we may have the MN1 queuing delay, perhaps suitable for your system, but perhaps no. But right now, let us ask you to consider this. Same as the previous scenario, we have 10 packets. 10 packets at a queue, waiting for transmission. All right, so this is a given value, and transmission delay L over R, assume it's for example, 1 second. All right, so the scenario like this is Q. We have 10 packets. And assume all the packets are in the queue already. And some of them put into the transmission line. All right, so the time is 1 second. Okay, so summarize, we consider the packet transmission scenario, but right now we further consider the queuing delay. If we have 10 packets already at the current output link and waiting for being transmitted, well, we know the transmission delay. So I don't have the transmission delay directly, but we ask you, what is the average queuing delay? All right, so this is a current example we ask you. Well, think about this, and of course I can save it. Later I can save it. So you just consider the question here. What is the average queuing delay? So how about first packet? Well, right now I ask you about the first packet. We simply consider queuing delay. So I don't have two choices. About first packet, queuing delay is 1 second. It's not 1 second, it's 0 seconds. So 1 second or 0 second for the first packet. If we consider the queuing delay. 1 second, raise your hands. 0 second, raise your hands. Okay, some of you, yeah, it's 0. Why is 0? Because the first packet is not necessary for that packet to wait. So being transmitted directly. So of course, 1 second transmission delay, but 0 queuing delay. So this one, 0 second, it's queuing delay. All right, and how about second one? If we consider the second one, why the second one needs to wait? Current situation actually waiting the first packet being transmitted, right? So because of waiting the first packet being transmitted. So being transmitted 1 second for the first packet. So of course, this is a queuing delay. Well, if you understand this, I think you can know this. We have 1 second multiply 9. Right? Because when the first one, second one to the ninth one, and all the packet should be transmitted, and then allow the 10th packet to be transmitted. So the queuing delay actually waiting for the packet before the 10th packet. So we have this. Well, this is an individual queuing delay, but we ask you to have an average queuing delay. So average queuing delay here. So about average, how to have the calculation? We have 10 packets. So denominator actually we have 10. But the numerator, of course, we use this one to this one. So 0, 1, 2, 9. And then this is the answer. Okay, so this is a way to have the average queuing delay. And the example here, actually I have the physical meaning, and you can feel why we have the queuing delay. And this example actually the same as the previous consideration. Alright, so about this, I think okay for you, right? Okay, this is the first example, and later we have some actual example, but not the real situation, but I did have some actual introduced notation so that we have some operator allow us to have for the calculation. So later I can continue. So that's it. Up to now, is it okay? If it's okay, take a rest. Later we can rediscuss this. All right. Take a rest first. Well, about the actual discussion, queuing delay, average queuing delay, this is way. So the first example. And the second example, asks you to consider this. We have a packet, actually all the packets here, but I assume packet 1, ice packet. Okay, the ice packet queuing delay. Follow this formula. Right, so first packet queuing delay is 10. Second packet is 12. Maybe you don't have any reason, but somewhat like someone measure the way and so that they find the formula. Well, this is the given. Actually, this is a first given condition, and second condition, consider 1,000 packets. All right, and what's the queuing delay? Well, this one in fact is really special. someone that you have the formula. And how to apply the formula to that you have for the, average queuing delay. Alright, what's the average queuing delay if we have the formula? And consider 1,000. Why? That you have a really large value, 1,000. Well, if we have these queuing delay, well, we have these 1,000 here, right? And we need to have the summation here. And from the first one to 1,000. And that's all. If we have these. All right. Here, I just want to mention, if we have these, remember the formulas? Right? This is the formula. And also, I already have the formula. And the third one, all right, this is a formula. If we have the formula, then you can apply the formula so that you can solve it, right? So about the current calculation, I already have the formula, but I do not calculate that one directly. So this is the result. All right, so about this, you can refer to the formula here so that you can have the calculation. Sure. No. Here, I already have the formula. I do not consider the previous example. Previous example, we need to wait the first packet being transmitted. At this time, we ignore the previous scenario. We don't have the new scenario. We don't have the formula. Queuing delay we follow the current formula 10I. Yes. So it's a different example. So this one not the same as the previous one. So I already have the formula directly. Someone find the formula and no other special reason. Yeah. Currently it's yes. 10I. So I already know 10 maybe 10 seconds. So a new example, not the example follow the previous one. No. About this is okay. But for this one, I just ask you to apply the special formula. We have the three special formula. All right. And in fact, we may have the situation to consider the example of the first one and also consider the extended example for the current example, so that we can combine the two. And how to combine the two? We may have for these. Let me save it and let me have a new one. All right, right now I have the third example. Here, assume ith packet. Maybe for some reason, transmission delay. Follows this. Even I have the same, maybe I change it to I. Okay, I second. All right, and same. Consider 10 as 1,000 packets. And here ask you what's the average queuing delay. Perhaps you feel why the transmission delay not the same. Perhaps we ask the packet different size, or as the capacity has vary, and so that you can have the formula. So maybe no special reason, but ask you to have the transmission delay follows I second. So first packet transmission delay is 1 second. Second is the 2 seconds, etc. But right now, follow the first example and second example. Here I have the mixture of the two characteristics of example 1 and 2, and right now we have this one. And ask you to have the queuing delay. And so the average queuing delay. So here, how to solve it. First packet, it's 1 second. 1 second. Oh, sorry. First packet, sorry. First packet, queuing delay is 0 seconds. This one the same as the previous one. But second packet, it's 1 second. And the third packet, it's 1 plus 2 seconds. Is it okay? Right now, the current example, same as the previous one. 0 seconds, because the first one can be processed rapidly, so it's not necessary to wait, so 0 seconds. But the second packet needs to wait transmission of the first packet, so it's 1. Third one is the delay, the queuing delay is waiting for the first one and the second one. Well, we can continue. Sorry, I have nth packet. Well, is it okay? If we have these, we will have an average queuing delay. Right? So about this is a calculation. Can you accept the current formula to have the calculation? So assume nth packet. So nth packet follow the formula here. Transmission delay of the previous packets. And so you have the formula, but the formula should be started from 1 to 1000. And if we have 1, actually the first one is 0, here is 1, so the index here disappears, so you have 0 directly. So about this, understand this one. If you have this, then it says how to have the calculation. In fact, you need to follow the previous formula to perform the calculation 2 times because we have 2 summations. About this, I think you can calculate for yourself and then you can understand. Alright, so this is an actual example. If we simply consider the calculation of arbitrary delay, we have the 3 examples for you for reference. Likewise, I will accumulate an example and so that you can look at the example again from Teams. Well, about this, any questions? Well, let me have for this, and so that you guys need to join Paul arbitrary.